So today so last class we learned that shapes were congruent if all their corresponding sides were congruent and all their corresponding angles were congruent. So for a triangle, two sets of triangles, or a pair of triangles, two triangles, that means I'd have three sets of angles and 3 sets of sides. So I would technically have to show that 6 things were congruent before I could say the triangles are congruent. Now, that's quite a bit to show every single time. Today, we're going to take a look at 5 shortcut methods that instead of having to show all 6 things are congruent before I say the triangles are congruent, I actually only need 3 things. So it depends with the different postulates and theorems. Each one tells you which one we're trying to find. But it's 5 shortcuts that allows us to more quickly show that triangles are congruent. So that's what's coming up to you today. Maybe I can get you notes. I'm taking a look. What's your homework for today?
Worksheet 3 and 4.
Worksheet 3 and 4. It's a bit of a heftier homework, but for worksheet 3, all you're saying is triangle yada yada is congruent triangle yada yada. For worksheet 4, all you're saying is side 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 side. Which I didn't see that. What is the word version I am thinking of? Oh, those for people checking the corrections. That has nothing to do with it. Which correction? 3? Was the reshape? 2 days ago. Today. Oh, okay. I did actually, so I can say that. Sorry, so I can yeah, look at that. I got it. Yum. Yum. There is no info on this class. Okay, so like I said, today we're learning 5 shortcut methods. Now these are postulates and theorems, and they are going to be your best friends. So we will be using these in our proofs, and we're going to use ways to prove triangles are congruent. So if we're trying to show triangles are congruent, we're going to use these guys. Okay. So again, originally we would have to show all 3 sets of angles congruent and all 3 sets of sides congruent, so 6 pieces. So A represents angle and S represents side. Just write that at the top. A means angle and S means side. Okay, so our first way to prove that triangles are congruent is what we call side, side, side. And side, 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 this is a postulate. I think only 2 of the theorems, yeah. So side, side, side is a postulate. When we use it in proofs, though, I'm okay with you just saying SSS. So side, 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 what this is if I have all 3 sets of corresponding sides congruent, and that's all I know, then I know the triangles are congruent. So if I take a look at number 1 here, I can see we have 1 set of corresponding sides, 2 sets of corresponding sides, 3 sets of corresponding sides. So based upon just those 3 pieces of information, I can say those triangles are congruent by side, side, side. Now again, when we write our congruency statement, that's what this is called. This is a congruency statement. We have to make sure we get the proper letters matching up. So it says A, B, C, so I want to mimic that same format. That's the 3 dashes, 2 dashes, 1 dash. So A, B, C would match up with D, K, X. So that's just doing the same thing from last time. And when you write your congruency statement, please take a couple seconds to just double check so you have in the right order. AB should match up with DK. Indeed it does. BC should match up with KX. Indeed it does. And AC should match up with DX. And indeed it does. I'd hate for you to lose easy points just simply because you made a slight error in the order of your letters. Okay. Side, side, side. Our next one that we have is going to be side, angle, side. Side, angle, side. This is another postulate. And this is going to match up with example 2 here. So notice that my angle is in between two sides. So there's two sides and the angle in between. Not the angle next to it, the angle in between them. So I have two sets of sides, and the angle is in between them. So this would be an example of side, angle, side. Again, based on just these three pieces of information, I can know that my triangles are congruent. So I have triangle RST. It's going to match up. Again, R was my starting point, so over here my starting point will be W. So RST matches up with WCS. Okay. Number 3 here. This will be our next one. We see we have two sets of angles and the side in between. So it's angle, side, angle. Angle, side, angle. Again, two angles and the side in between them. The side has to be in between. So this is our postulate. It's not the side next to them, the side in between. So again, one angle, side, and another angle. So these two triangles are congruent, but angle, side, angle. Again, make sure you're careful with the order of your letters. Triangle RST, so it's the one arc, no arc, two arc. So I'm going to go one arc, no arc, A, two arc, F. Okay, questions so far? So it's the same idea, just variations. Any thoughts as to what number 4 might be? Angle, angle, side. Angle, angle, side. So it's two angles and the side next to them. Angle, angle, side. Again, notice my side is next to them, not in between them here. This one's actually a theorem. And again, we know right angles are congruent with one set of angles, then the angle next to it, and then the side next to that. Angle, angle, side. Angle, angle, side. So these two triangles are congruent by angle, angle, side. And again, careful with the order of your letters. Triangle MZP is congruent to triangle what? WRT. WRT. Okay. So far we have side, 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 angle, 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 side. Our last one is completely different. It doesn't use angle or side at all whatsoever.
What? Why? Who made these kinds of... That's so stupid.
So it's not nice.
I don't like when that's so...
Discovered it. Alright, so this is only for right triangles. Only for right triangles. And this one is called H. But it is a theorem.
I hate this.
What do you guys think the H stands for? If we're talking about right triangles. Hypotenuse. Good. And leg. Good. So we have hypotenuse.
Dynamic zero.
And leg. So even though these other 4 methods require 3 pieces of information, HL makes it look like we only need 2, but technically it's still 3 pieces of information because only right triangles have hypotenuses. Hypotenuses. So technically we first have to have it's a right triangle, and then we have to have a set of legs congruent and the hypotenuses have to be congruent.
I like
Hypotenuse. Hippopotami?
Yes.
What would it be? Hippopotamuses. Okay, so for number 5 here, we have it's a right triangle. Now, just because it is a right triangle does not automatically mean HL. It's just an option that only works for right triangles. So it's possible to be hypotenuse-like. So let's take a look. Do we have our hypotenuses congruent? Okay, we've got hypotenuses. Do we have a set of legs congruent? Yeah. So this would be HL, hypotenuse-like. We would have triangle BNT congruent to triangle CAB. For number 4, could I use hypotenuse-like for that one? Mikhail quickly shot that down. Mikhail, why can't we use hypotenuse-like for it?
There's an angle there.
True, they did give us an angle, but why else could we not use it?
Because both legs are, or one of the legs are.
Yeah, we've got hypotenuse, but we don't have a set of legs. So just because it's a right triangle doesn't mean HL. It actually have the H and the L. Okay, so these are 5 shortcuts to proving triangles congruent. Now, to the great disappointment of many of you, you'll notice that we have nearly every combination of sides and angles. But there is one that is not there. No one say anything. When we take a look at this, if we were to read it backwards, it would be a bad word.
I like that.
We don't have bad words in math. But that's not the only reason why it's not a method. So this is not a method. Do not ever write this because it will never be correct and it will guarantee be wrong and maybe doubly or triply wrong. So that is not a method. And the reason why it's not a method, let's see if I can kind of illustrate it here. I'm going to use this example here. So when I have angle followed by 2 sides, because there's no indication of the measurement of these angles, and there's no indication of the measurement of these sides, then what that means, I could take this side here, and it could swivel to be over on this side, right? Because we don't know what the angle is, so it could be that the angle is small. We don't know what the side length is here, we don't know what this angle is. So technically, there are 2 possible triangles you could have like this. This guy, or if I were to take this same length, I'm going to approximately. This picture could technically be either of these 2 triangles. So that's why there's not enough information, so I'll scribble this away. We don't have enough information to know, are they the same triangle or is it that they're actually the 2 different triangles? So it would be insufficient information. That is why that is not a method. 1, it's a bad word, we don't use that in my classroom. But also, it doesn't work because there's not enough information to guarantee that the other angles will be the same. Now, there's another one that's not represented. So, what other possible combination of sides and angles is not here?
All angles.
Angle, angle, angle. Why does this not work to prove they're congruent? Right?
Because like knowing the angles doesn't mean you know the lengths.
Right, so let's take a look at, let's see if I can use my big smart board here. Okay, so here's a triangle, and if I clone this, I have the exact same triangle, those would be congruent. But all I need is for the angles to remain the same. The angles did not change, all I did was make it larger. Are these congruent? No. The angles being the same only guarantees that it's the same type of triangle, but not the same grouped triangle itself. We would call these triangles similar, but not congruent. So that would be next unit. So that's why angle, angle, angle also does not. So we are stuck with these 5 here. Side, 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 angle, side, angle, side, angle, 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 side, and I think that. So I'm going to write that off to the side. These are what we'll be using today. Now, when you get to pre-calculus, should you decide to take that in the future, You will investigate in this scenario with the side-side angle. You'll investigate how to find those two different triangles. So you'll actually use law of sines, law of cosines to find the two different triangles there. Okay. So pretty easy and basic when we just have two triangles with all those perfect markings on it. But that's, of course, not always going to be the case. Here, put it down if we can't handle that. We will have triangles next to each other. We'll have triangles overlapping. And we won't always have all the information given to us. We have to apply what we know from our previous units. So this page are just some examples where triangles are sharing the side. So for our first one here, they're next to each other. So I can say this triangle, so that's what? TMW. We actually have two triangles next to each other now. So TMW is going to be congruent to XMW. What method would I be using? Yeah, side, side, side. They gave us all three sets of sides. Sweet. All right. Let's take a look at our next one. I have, let's see, ABC is what they're talking about. When I compare that to ADC, we only have two sets, or two pieces of information. I have these angles and these angles. Yeah, so would you guys agree that they share AC?
Yeah.
Does AC change in length from one triangle to the next? No. So we can say that this is congruent to itself. AC is congruent to itself. What would be my reasoning for that in a proof?
Reflexive.
Reflexive property, good. Now, you don't have to justify this unless they ask for it. I think worksheet 4 asks for it. But I'm just gearing you up towards our proofs. So we know that that's congruent to itself by reflexive property. And then now I have angle, angle, side, angle, angle, side. So I can prove it now by angle, angle, side. So we have a triangle ABC is congruent to triangle ADC. Again, make sure you're careful, get your letters in the correct order. All right. How about our next one? Oh, looky there. MK is congruent to itself. Can I say these triangles are congruent? Side angle, that word.
Oh, yeah.
HL, good. We have it's a right triangle. Sweet. Hypotenuse, yep. Legs. Good. So let's see. Make sure you're careful with this. MQK is congruent to
Wait, MQK or MKQ?
It says MQK.
K or K.
A N N. Correct. So this is something else you want to be careful with. When they start sharing sides, they're going to be sharing those vertices. That does not necessarily mean that those letters will be in the same location in our congruency statement. NQ is our one tick mark. So we want to make sure KN is in that location. So when it says NQK, that was the one tick mark to the right angle, and then the other one. So we want to mimic that. One tick mark to the right angle, and then the other. Again, once you're at your congruency statement, take those few seconds to make sure NK, KN, this should match up. NK, yep, okay. NQ, KN, indeed. And then KQ and MN. So always do that double check just to make sure you didn't accidentally put it in the wrong. Okay. Did they give us anything congruent?
We know they're parallel.
We know they're parallel. Our parallel lines congruent.
They have the same.
No.
I got yeses and I got nos. Our parallel lines are congruent.
Miss Margaret, what's the definition? Like the definition.
What's the definition of what?
Congruency. Because I know that they're the same, but that's like the dumbed down.
So then equal measure. So like congruent angles are angles with equal measure. All right, so parallel lines, are they congruent?
Not always.
Not always, right? Because I could have parallel, are those congruent? Nope. So just because we see parallel doesn't mean that they're congruent. Oh, not legally. Make sure I give this to the correct person. Okay, so parallel, they're not congruent. So just because they're parallel, maybe they're congruent, maybe they're not. So don't automatically assume that. We'll take a look at what else we do know. Oh, but wait, Mrs. Margaret, we learned parallel lines in Unit 3. We know stuff from there. Why, yes, we do. Let's take a look at these set of parallel lines. Oh, how convenient. We have a transversal here. Would you agree that these are congruent? Oh, what's our method that we use there? Alternate interior angles theorem.
What's the dotted line called again?
Transversal. And then I have another set of parallel lines. Still have this transversal. Another set of alternate interior. Okay, we've got two sets of angles.
Angle.
So I've got two sets of angles. What else do I know?
The transversal.
Yeah. I lost my letters there. Is that F and B?
That can be.
Yeah. So BF is congruent to itself. So we would have angle, side, angle, angle, side, angle. Okay, so we've got to be careful here. I'm going to erase so I can see my letters a little bit better. So it says RBF is congruent to what?
EFE.
EFE, good. RBF, EFE. Okay, so we used over here alternate interior angles here. I want you to write that off to the side. Just when you're looking back at your notes, you're like, oh, that's something that we can use. Alternate interior angles there. Okay. This one's too easy. Try that. Side angle side. Good. Triangle WYZ. Triangle WXZ. So alternate interior angles, really anything from our parallel lines we could be using, but alternate interior angles are more common when we get our parallel lines, and then that reflects. Okay, let's take a look at the next page. So this says triangles with hidden information. So again, we have to apply what we know from previous units. So we said with parallel lines, we can get some stuff, alternate interior, sometimes corresponding comes into play. We have reflexive property. We take a look at our first picture up here. What else could I say about that picture? Vertical angles theorem. Yes. So I can say that these are congruent by vertical angles theorem. Again, let's just write that off to the side just so you have a heads up that we use that. We use that one pretty often. And then now I can say these are congruent by side angle side. And then let's write our congruency statement. Put it away. Again, our congruency statement, it's not so important the order of the letters as it is which letters match up. So here they did not fill in half of it. You can fill it in on your own. So when I am checking your answers, I'm going to make sure, like you might have your letters in a different order than mine. That's fine. I'm just checking to make sure you have the same corresponding letters. So I'm going to go with C and D. C and D. And that would match up with A and B. You might have gone in a different order. Maybe you said triangle DMC. That would be fine as long as you then say triangle BMA. Okay, so what I'm doing is I'm looking to see that C and A are in the same spot. That M and M are in the same spot. And that D and B are in the same spot. So if on your homework you'd like to write it vertically, it's a little bit easier to check it that way. That's fine. Okay. Questions on that first one? Alright, so our next one here. We've got vertical angles again. Sweet. What else do I have? Chris?
The parallels transversal or vertical stay as your alternate interior.
Very good. So I've got my parallel lines here with a bit of a crook in it from the smartphone. And we can honestly use either one as the transversal. So what do you guys want to use, UI or TR? TR. I heard more TR, so we're going to go there. So I have this, and this would be alternate interior. So what would be my method that we use here? Yeah, angle, side. If you write side angle, that's fine. It's just, you'll always see it written like this. If you write it backwards, it's the same. So angle, side. And that would be by, okay, I lost my letters again.
TR.
How's an angle side when the angles are next to each other?
That's what we want. We
I mean,
want.
they're not next to each other. They add the other end.
That's fine. So we're going to go that way. So that will give you a different reason,
Yeah.
which is fine. You can do that. Okay. So we had we go TUM, tongue. TUM would match up with what? Good. RIM. Okay. So now what this is leading to is that what if we use the other transversal? So let's pretend. TUM, yep. TUM, and then RIM. I want green. I want this to be green. Okay, so what if we still did vertical angles, but we instead did the other set for the other transversal? Then these would be my alternate interior. Wait, what? What? These would be my alternate interior. And notice now my method would change. Now I have angle, side, angle. Angle, side, angle. Our congruency statement would still be the same, but our reasoning for it would be different. So this happens sometimes where, because there's more information than we need, there might be multiple ways to approach it. So when I'm grading your assessments, I look to see what markings do you have on your picture. Does that match up with what statement you've chosen? Okay, so just make sure you mark on your picture. If you chose to do it this way, that's fine, as long as you have angle, side, angle going with it. What if we didn't do vertical angles at all? Would that work? What if we did both sets of alternate interiors?
I think you do.
What's that?
You keep putting it on the wrong side.
I know. What would be your method for that? Angle both sides, so it'd still be the same as this guy. But so again, there are three different ways we could go about that. And remember, parallel does not mean congruent. All right. Let's take a look at our next one. The overlapping triangles. Oh no. Whenever you have overlapping triangles, I highly recommend you redraw them separately. And then let's go into information that we have. So we have angles Q and U are congruent. And then,
What couldn't it have been QT?
so that's this guy here. So ST. And then, what's this triangle? SR. Okay. So right now we have two pieces of information. Let's see if there's anything else we can get. Taking a look at our picture here, any thoughts as to what else we could say?
QT.
QT.
But if you congruent,
Do we know that they're congruent?
Is angle S?
Angle S the same, and what else? We have vertical angles. So let's take a look at both of those. So we've got vertical angles within here.
Oh.
Now, sometimes that's advantageous for us, sometimes not. Let's take a look. So in our picture here, we've got vertical angles. Does that help us out in our overlapping? No, that's just part of it, but it's something to keep in mind. Sometimes that's how it works. And then what was the other thing you guys said? Angle S? Do you guys agree that S is shared in both of them? So angle S here is the same as angle S there. Is that enough now?
Yeah.
Oh, what method?
Angle.
Angle, side.
Wait, how do you decide if it's angle on the side, angle side?
Also, how do you know?
So angle, side angle. The side has to be in between the angles. My side is next to
We're
it.
all on one line segment.
So like if I wanted angle, side angle here, it would have to be the angle right next to it. So like you're not skipping any information. For angle, side angle, it has to be literally the side in between the two angles that make it up.
So it couldn't be angle.
But angle, side is two angles and then the side next to it. It could be that it's this side or that side, as long as it's side
How
next
do
to
you
it.
know that the congruent lines are SR and ST? Because technically the line is like on.
So congruent markings are always going from point to point.
I know, but when you look at like, if you look at triangle ST in the overlapping picture, the line is like also on the hypotenuse, and then if you look at SRU, if the other line is on the
But it's only talking about a portion of it. So like I don't know SQ and SU, I only know from here to here is the same. I don't know if the whole thing is the same. So when they do, markings on the picture are always from point to point. If we wanted to say that SQ and SU are the same, they would have to write that out separately.
But then how can we know that it's part of this?
Because it's from S to R is the point to point.
So if it's in the middle, then? Because it's also from point. Okay, no.
From the closest points to it.
Oh, okay.
It won't represent SQ, they'd have to write that separately because there's too much happening. Does that make sense? All right, other questions? Oh wait, we got to write out our congruency statement. We can go STQ. So that would be what? SRU. Good. Okay, questions with that? I never knew there was so much you could do with triangles. All right, I want you guys to try this one because it's pretty similar to what we've done before. Decide what method, write your congruency statement.
This one is the same. This line is shared by both sides. This will be all interior angles.
So angle S.
Okay. I got the song.
So is it H sine? So it's H and
It's signing one inside.
no, but then the first
That's what I would do.
I G H I S.
But it's not the same line. It's a different.
A song. I'm doing HI.
All right, do you agree with these markings I've added to the picture? Okay, I saw Kira agreed, but no one else. Does anyone else
I
agree?
agree.
That's all the.
That's all that matters.
That's all the validation.
All right, so I have angle, side, angle, angle, side, angle. Do be careful with the order of your letters. I'm going to go H-I-F. Okay. So H-I-F, I started with the one arc. I'm going to start with one arc over here. F-G-H. So you might have yours in a different order. That's perfectly fine. Check and see. H and F go together. I and G go together. F and H go together.
I say HDF.
Do the same letters go together? They do? Okay. All right, so we have questions on that one. Alright, let's take a look at the back side. So here's some examples in which we don't have enough information, where none of our shortcuts work because we don't have that information. Just make sure you follow the directions. Sometimes it tells you to write not enough info, sometimes it tells you to write insufficient info. If it doesn't say which one to write, just read either one. We already addressed some of these. This first thing here, our issue is that it's only angles, no sides. So the reason why this is insufficient information is what we talked about over here, where we have these are similar but not congruent. They might be congruent, but we don't know. Like not necessarily congruent. They could be. So angle, angle, angle is not. All right, what's my issue with this one over here?
You only have one side and one.
Yeah, we only have one side, one angle. If we try to use like hypotenuse leg, we've got the hypotenuse, but I don't have the leg. So just not enough information. We talked about our issue here. This is a bad word. But we talked about how the real reason is that we don't know which triangle is represented.
Wait, can you explain that again?
Yeah, so what we have is the only information we do know is that these angles are the same and these are the same lengths. Okay, so I'm just going to mess with that. We don't know what this angle is up here, so I can swivel this.
Oh, okay.
Because we don't know that angle and we don't know the side, so I can change the side length and the angles there, but keep the other information the same, and there's two potential triangles. Okay, what's the problem with the last one? Grace?
You have side angle side versus side angle.
Good. We've got the same amount of information, two sets of sides at an angle, but notice the locations don't match up. Here we have this as side angle side, but here my angle is not in between them, so it's not side angle side. This is the bad word. So we don't have corresponding matchup. So what we mean by that corresponding is that it's the same order. It's not just that I have two sides and angle, but it's in this particular order, the angle is between the two sides. Here my angle is not between the two sides, so it's not matching. Okay, I want you guys to go ahead and try these bottom ones here. You can work individually and then check with your shoulder partner. If you just want to tackle with your shoulder partner, that's fine. But go ahead and do this.
We can't do the first. We never do it.
Not enough.
The first one is not enough. What would you say?
You can just write not enough info.
Angle.
Yeah, guys, if it's not enough information, you can either write insufficient info or not enough info.
Do this.
I think that's okay.
What number?
We'll go for it.
A.
7 would be
Side by side.
side by side.
Yeah.
You ever see this?
2.
Not enough.
I got it. Wait, then what did you get for number?
Not enough info.
Angle.
Yeah, you can just draw it on. Yeah, that's correct. In a proof, you would have to justify with reflexive property. But if it doesn't ask for justify, you're good.
No.
Oh no, it was not.
You can't solve that one.
Yeah,
They're on, like,
side.
Yeah, you can't solve that one.
Should we simplify not enough info to any other?
That's what I was just debating with Mikhail. I feel like I'm going to accept that. Yeah,
What would be the difference
it would be fine. Yeah, so you'll never see it written that way. Like I will always continue this format, but if you flip the letters around, it's the same thing.
Wait, 8 is not enough information because that's
It's a bad word, yeah. It's a bad word.
It's a bad word.
Bad word. Can you write bad words?
Not enough info.
Side equals side.
It's on.
Don't ever trust the picture. Don't look at the picture.
I have one tick mark, one angle.
And then no,
Yeah.
you can do the thingy with the thingy. And then like you do the parallel line stuff.
You make so much sense.
I know. Look, you can do the thingy with the angles, and then so that would be
How do we know the angles?
with the parallel
No, you can't do that.
Okay, so we have one.
Miss Margaret, we're having a debate here. So for number 6, I said we could do this one because of the angle with the line transversal thing, so it's all interior.
So I like your things that would be. So you got the idea, but the wrong set of angles. We're getting the alternate interior. Alternate interior. Correspond. That doesn't work either because alternate interior on the other side.
So which number
This side could be swiveled. Like remember the pictures, although they're drawn, they might look similar. They're not. So this.
No, be angle, side
What we
angle.
have is basically triangle. So whenever it's backward, it's on the side. That one These are pairs. And then you can do this. You can do the same. The reason I changed it is just because at the end.
Why are there so many any items?
No, but we do the same thing.
What did you do? What does that even say for not enough?
Yes, I thought you already
Alright guys, let's go ahead and bring it back to the front. Alright, what did we get for number 1? So Mikhail convinced me
You're welcome.
that we can use this abbreviation.
You're welcome.
You should rejoice, this is the first year I've ever allowed that.
I'm just so convincing. My
Alright,
innocent face.
number 4, we have this as well. What's your method here? Good, angle, angle, side. Alright, number 7. Good, side, side, side. Number 2. Nay.
Nay.
No.
No, thank you.
Nay. Number 5.
Hey,
Side, angle, side.
excuse me?
So again, we just need to make sure our corresponding information matches up. I have a 1 tick mark, followed by a 1 arc, followed by 2 tick marks. It's basically just that. Nay.
You just make your dollar day.
No.
You have names in mind.
It should have figured out yet.
Backward.
Alright, number 8.
Alexis,
Okay, so bad word is true, but not enough information.
Bad word should also
Mia
be
Texas.
Bad word. If you write bad word, although that is true, it's a bad word. That's not the correct answer.
We're gonna get marked off if we say bad words.
You will get marked off if you say bad
Okay,
word.
what if you write bad word and NEI?
Then you're okay. Okay, as long as you have the NEI.
Can I do bad day?
All right. Number 3 here.
Ah.
So angle, side. Okay, now number 6. You want to be careful. We don't have we can draw alternate interior angles, but they're not helpful. If I did alternate interior here, that would be this angle and this angle. That angle is not inside my triangle. So if you tried alternate interior didn't work. What do we have to use instead? Corresponding. Hold up, right? Okay. So I have corresponding. That's one set. And then I also have corresponding this one.
I have one thing to say.
Okay. So using our method here, what would that be?
Angle, side, angle.
Angle, side, angle. Okay, what do you want to say?
Okay, so in the alternate interior angles,
Okay.
the alternate interior angles of each one, they share the middle one, so if 2 angles are congruent to the triangle, there.
You can do that, yeah. Very good. So let's just say we have alternate interior this way, and we have our alternate interior over here, and then we would have transitive property, and those would be here. Okay. So then if you chose to use that, you can do the angle both sides. Yeah. So just again, make sure you have those markings on your picture.
So it can be outside.
As long as you did it that way, yeah. So you have to show all 3 pieces there. So in a proof then, you would have alternate interior, transitive, and then you would be good to go. What's that? Yeah, then you're good.
What's this one?
Very good, Rick. Okay, so you could also have angle side using that guy. All right, number 9. We have overlapping triangles, but we didn't have to do anything additional. We did that, right?
It's definitely.
Angle side. Okay. Questions with that?
Check out the day.
Okay. Now I want you to draw this somewhere on your notes. This guy here. I know. There's, you can find space somewhere. And let's call this.
No, take no.
We'll just go around.
First page.
A, B, C, D. Oh, this one.
I'm not just me for that.
So we have overlapping triangles appear pretty often. But there's this one particular kind that there's a lot we can do with it when at first it doesn't seem like we can. So I want to draw our attention to this. I think you have this type on your homework. So here we have overlapping triangles. But we also have what I call these bow tie triangles. So we always have to check all possible sets of congruent triangles. So I'm going to go ahead and draw my overlapping separate. So if I have this. Okay, I'm going to make that smaller because it's not going to be enough space. So this would be triangle AEB.
I can't do that.
So again, whenever we have overlapping, I highly recommend you draw it separately. And this would be C. And again, let's go and draw that action information. So I have A and C were congruent. And AE. And CD. Okay. Yes, please.
Are you, do you know that you're supposed to include those triangles, or can you do 2 or 3 small?
So whenever they give you a picture, you want to check for any set of congruent triangles that you could possibly
So you can also prove AB here in the same.
Possibly so, that's what we're going to find out. Okay, so I'm going to start with my overlapping. What other information do I have about my overlapping that I can say? Just
There's vertical angles.
good, so we've got our vertical angles in here. Now, in my overlapping, that's just part of this side here, so it doesn't help us out with our overlapping, but that will help us out with something else. What else do I know about my picture? Roland?
E is shared.
Good, ED is shared. Alright, for my overlapping triangles, do I have enough information?
That doesn't work.
Bad word. Okay. I don't think there's anything else we can draw in our picture. So overlapping right now, we don't have enough information. But let's take a look at what I call the bow tie. These guys, right? Okay. Now for my bow tie triangles, you probably don't need to draw those separately because you can see it from your picture. But just so you guys can see it up here. Do I have enough information for my bow tie?
Yes.
Yeah. I can say that triangle, what is that, ABE is congruent to triangle CBD. And that would be by what? Good. Angle, side. Angle, side. Awesome. Now, last class we learned something that's very important called CPCTC.
Oh shoot, what?
This isn't just merely cats play cards Tuesdays counterclockwise. What does CPCTC mean for us with our congruent triangles?
So mean that, isn't that like the big congruent triangle? And the triangles are congruent means that all the sides are all sides.
Perfect. When our triangles are congruent, all those pieces are congruent. So now that I've said, hey, guess what? My bow tie triangles are congruent. Now I can fill in, well, if my triangles are here are congruent, then I know my matching sides must be congruent. So this must be congruent to that, right? EB and BD. EB, CD. Likewise, this must be congruent. Oh, wait, I already used 2. Let's make that 3. And we can fill in our last angle. So basically what we've done here is we first proved the bow tie was congruent. But now that we know it's congruent, then we can fill in what pieces match up. Now this is super helpful for us when it comes to our overlapping triangles. Because now that we've shown those are congruent, now I can fill in some more information over here. Usually the fastest thing to fill in is take a look at this whole stretch here, CE. Notice how it's made up of a 3 mark and a 4 mark. And AD, notice how that's made up of a 3 mark and a 4 mark. So would you guys agree then that this would be congruent to this?
Yes.
Yes. And now we can say that these triangles are congruent. Triangle AED is congruent to triangle CDE. And we've got some options here: side, 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 angle, side. Don't use the bad word. I feel like side, side, side is usually the fastest. So we do actually have enough information for the overlap. We just had to first show bow tie was congruent. And then once we have it, we can use CPCTC to get the remaining information. Now, my caution with this is just because you see overlapping, that doesn't automatically mean this is going to happen every single time. I gave you a triangle that had enough information to get there. It's not always going to be the case, but always check for it. Check that bow tie, check the overlap. Sometimes we get the overlap first, usually it's the bow tie first. Okay, questions on that? Okay. So your homework for tonight is worksheets 3 and 4. I'm going to give it to you in just a moment. I want to take a look at the directions for it, so well, that's not helpful if you can't read the directions. right. So calm the giggling, listen carefully. On worksheet 3 here, again, make sure always that you read and follow the directions. For worksheet 3, it says state the reason why they're congruent. That's talking about our 5 shortcuts. And then it says to also write the congruency statement. So you're going to be writing, again, this is our congruency statement, and then what method you use. Now for worksheet 4, for worksheet 4, it doesn't require that you put the congruency statement. It says state the theorem used to prove the triangle is congruent possible. So again, that's our 5 shortcuts. But they want you to list anything else you use. So like if you use reflexive property or vertical angles theorem, just list that off to the side. So you don't have to actually say triangle ABC is congruent to triangle CBA. If you want to, you're more than welcome to. But just know that. Okay, so let me go and hand it to you. You can go and start working on this for later class, and that's what we have for next class.
We haven't given it.
So good.
No, you can jump pretty good. Yes, we are. This is my favorite. Doesn't work, but it's okay.
Is there a back?
Do it right. Fine. Only if you do. Take you from.
All right, worksheet 3 is out. Worksheet 4 is coming to you. Yeah, you're gonna write triangle. Yeah, like this. Thank you for the way to go.
Okay.
For you to do it twice.
We have an extra.
You need an extra. You have an extra.
Oh, I just started grabbing mine.
Why is that taking? Oh, wait.
Okay, is there one that did not get worksheet 3 or worksheet 4? Everyone should have 2 in their hands. All right, so go ahead and start working on that.
There are some questionable letters on this.
There probably are.
Wait, let me
Which one?
Which one?
Oh, there's a little bit of a gap for C.
Okay,
Yeah, O's in the middle.
I'm looking up.
Quiz on Monday is over lessons 1 and 2. So what we did last class, what we did today. So quiz on Monday, keep that in mind over the weekend. Guys, as you're doing your congruent triangles, something you want to be careful with is make sure you're not assuming information. If you put a marking on your picture, you better be able to justify that with something. You have to actually know they're parallel lines before you do alternate interior. That's the big mistake people make. So make sure you don't assume information, put down only what's possible.
Exactly.